Welcome to solverfy.
Okay, so for this problem, you have this loop who's has a flux going through it given by a certain formula. Let's go ahead and draw it. Oh, it's a little lopsided, but I don't think that's super important. Our magnetic field is kind of like this. I guess I should actually draw it in the loop, etc., etc. So the B field's coming out of the page. And our goal is to get the EMF induced and then the direction of the current through this resistor R. So we're given that the flux is 6t squared plus 7t. So, and then it's given in units of milliweber. Honestly, I don't really know the symbol for Weber. I'm just going to call it Web. It's not very commonly used. And then, so to get the EMF, we of course want to take a derivative, dB, dt, and it's the negative of that. And there's only one loop, so we don't need to multiply by n. I keep writing dB dt. Sorry, it's d phi b dt. And so we just need to take a time derivative of this. And then it also asks for what it's going on in 2 seconds. So I'll just write that in our kind of givens corner. T is 2.0 seconds. So yeah, we just take a derivative of this and then we get the EMF. So that's 12t plus 7 evaluated at t equals 2. And then this is all negative. Oops. Negative. And then let's just keep in mind that the units are milliwebers. So at 2 seconds, this is minus 31. And then if this is milliwebers, then this is going to be millivolts. So minus 31 millivolts. And then the question is, which way is the current going? So there's 2 ways to think about this. The first way, I would usually not think about it this way first, but since we've already done this math, I just want to kind of, I think it's a nice segue. So first of all, this negative sign, what does that even mean? So that means that the convention is that you, let's kind of go back. So this B field was out of the page. For the flux to be positive, which it is, that means you can construct this area vector for the loop to also be out of the page. And so the convention is if the current is negative, or excuse me, if the EMF is negative, then you put your thumb in the opposite direction of the area vector, and then your fingers curl around to give you the EMF. So that's the EMF is therefore clockwise. If we received a positive number for this, it would be counterclockwise. In general, you put your thumb in the direction of the area vector, and then your fingers will tell you the direction of the associated current. The other way to think about this, which I would have probably done if I were asked this question before computing all of this, is to remember that the current acts to reduce the change in flux. So think about what the flux is doing. It's actually getting bigger and bigger, right? So this B field is kind of growing and growing and growing. And I like to think of like the current is like saying, I really don't want this growth to happen, like almost for it to have a personality. I think there's really another quick way to think about this than to prescribe this kind of silly narrative. So the current's like, please don't increase my flux. And so the current does all it can to sort of to mitigate this increase in flux. And what it does is it drives a current that would produce a magnetic field to oppose this change. And so to oppose this change, we need a magnetic field into the page. And therefore, to create a magnetic field into the page, you need a clockwise current. So for B, then the answer would be the for a clockwise current would go to the left on the resistor from right to left.